Online transaction processing, or OLTP, is designed for managing high volumes of short, fast, and concurrent transactions, such as data entry and retrieval operations. OLTP systems solve the problem of efficiently handling numerous simultaneous transactions, making them essential for sectors like banking and retail. Joran Greef is the founder and CEO of TigerBeetle, which is developing an open-source financial transactions database focused on mission-critical safety and performance. He joins the podcast to talk about the TigerBeetle's technology and problems it solves. Gregor Vand is a security-focused technologist and is the founder and CTO of MailPass. Previously, Gregor was a CTO across cybersecurity, cyber insurance, and general software engineering companies. He has been based in Asia-Pacific for almost a decade and can be found via his profile at vand.hk.
Hi, Joran. Welcome to Software Engineering Daily.
Hi, Gregor. Pleasure to be here with you.
Yeah, very exciting to have you here today, Joran. You are is it founder or co-founder of TigerBeetle?
Founder and CEO, creator of the project originally, and then we spun the company out with two co-founders from the company we were at. So three founders, but the whole team are sort of, founding team.
Awesome. So, right, straight out the gate, I'm going to just get one thing out of the way, the name, TigerBeetle. Talk to me about the name.
TigerBeetle was like a skunkworks project. We've been working on a central bank payment switch. We were consulting on it. How do you make this thing faster, safer? So we were just doing analysis, like everyday work on some big system. And while we were doing that work, we realized, wow, there's a way to make this system 100 to 1,000 times faster. So we had this idea. And then we pitched the idea. It went around a little bit. Then we sort of prototyped the idea, 5-hour prototype, and then people started taking notice. At first, people didn't believe that you could go 1,000 times faster just with an idea. So we prototyped it in 5 hours, and that became like about a month of prototype work. And around that point, this was July 2020, 4 years ago, and it was like birthday month of the project last month. But then we realized, okay, if you want to change things, you need to put a name on it. Like this little it was an idea and then a skunkworks project. And, we're still doing the consulting work that we had to do. But in the background, we've got this like, wow, there's this way faster way to do this. So we needed a name that, people could rally around the project and say, it's this project. And what we were looking to capture was the idea of something that's incredibly fast, like world champion speed, like really, really fast, but at the same time, really small, really humble, really light, really like cost efficient, very small footprint. And at the same time, something really tough, like lean and mean, something that can survive like all kinds of challenging environments. Because for this switch, it's kind of like you've got to be really rugged. This thing's just got to work and be rock solid. Kind of like a thorium reactor, and you go home at night in the lab and you just switch off the power and that's it. It's very safe. So we wanted something fast, small, and incredibly safe and tough. And a friend of mine, we still share an office today, Donovan Chankfoot. The two of us were doing this work together. And I said to Don, just over text, I said, we're going to need a name, for this project. And straight away, I was so lucky because normally coming up with a name is a pain. One of the hardest things in computer science and business is, or just any endeavor, getting a name. But within about 3 or 4 minutes, Don shot back to me. He says, TigerBeetle. I said, why TigerBeetle? He said, well, it's a fast insect, fast beetle. And he had Googled, fast beetle, and Google came back to Don and said, TigerBeetle. I did the same on my side. I typed in fast beetle straight away, and Google came back with Volkswagen Beetles, those very slow, old, big, the old cars. And Google Images was full of these cars. And to this day, I still get different results. So I'm glad that I had someone else come up with a name, and that's TigerBeetle. Yeah, fascinating creature. So it really is It's in the top 2 of fastest creatures in the world scaled for body size. It's like 1,100 miles per hour relatively, and it can detect bat echolocation and send a signal back to the bats. It's like technologically advanced as a creature, fascinating metallic colors. When you zoom down to its size, it's a real predator. It's a really scary creature. So we thought, wow, okay, this is perfect. And it does thrive in tough environments. So.
That's amazing. This is an incredibly functional name, even though it sounds just like a cool name. So I love that. It wasn't just a sort of, it's my favorite beetle. There's tons of functional reasons behind it. Yeah.
Yeah, it became my favorite beetle, and now I've learned, there's papers written about it, it's so fascinating, and related beetles as well, amazing, what people can learn, like all the biomimicry things, like there's something called a rhino beetle. Apparently the way that flies defies physics, and aeronautical engineers are trying to figure out how it does that, because we could make better planes.
So we'll get to what is TigerBeetle that we're talking about, I guess. But I think that context is actually really fascinating, because I think given all the sort of properties that you just sort of outlined there, and speed obviously will come into this in a big way. So we're going to talk about what on earth is TigerBeetle, and the project and yourself came to sort of our radar. You write some really great articles around what you're doing, and one recently was talking about the history of transactions, and I love financial history generally, so that straight away got my attention. But then I sort of was like, hang on a second, am I reading what I'm reading correct? That this project is what it is? So I would just sort of not exactly quote, but in that you mentioned sort of stumbling into sort of a fundamental limitation in general purpose database design for transaction processing. Can you kind of walk us through, I guess, the call it eureka moment, in terms of how that then led into what TigerBeetle is, and sort of maybe just if you can give it in a one-liner, what is TigerBeetle?
So let's start LIFO order, last in, first out. TigerBeetle is a financial transactions database. It's really a transactions database, or OLTP, online transaction processing database. We say financial transactions database to help people get into it, but really it's a transactions database for transaction processing. So the question is, as we look at, what's this fundamental limit that we stumbled into in the general purpose design of these fantastic databases, Postgres, MySQL, they rule the world, for a reason. They're here to stay. They're general purpose databases. If you want to build an app, that's Postgres. You can build anything general purpose. For a long time, these general purpose databases were used for everything. They were used for OLTP. They were also used for blob storage and queuing and for analytics, and then in the 90s already, Edgar Codd in 93, he coined the term OLAP, because people realized that, analytics, and obviously TigerBeetle's not analytics. This is just a little bit of history, as we look at what is a transaction, what is a transactions database. So we will get to that. But just a bit of the background context first is that these general purpose databases, Postgres, MySQL, they're 30 years old. MySQL was 1995, same year as Windows 95. Postgres was 1996. So they're amazing databases. They've been used for everything, and they were used for analytics. And then in 93, Edgar Codd coined the term analytical processing, and sort of OLAP spun out. And today you've got ClickHouse, you've even, got DuckDB, like flagship of analytics. You've got Snowflake, Databricks, all these. There's such a whole world now of analytics, and the anatomy of an analytical database. It's not an elephant, the Postgres mascot of the elephant. The anatomy of an analytical database is a duck, DuckDB. You switch from thinking in terms of rows to columns. And the whole, anatomy, as you pop the hood of this database, look at the way the car is built, the engine, it's totally different. It's an alien creature compared to Postgres, the elephant. It's a duck. It's not an elephant. First thing, and then up until now, these general purpose databases have been used also for transaction processing. And so much so that, people will say Postgres is an OLTP database And it's a general purpose database. I think in our minds, intuitively, we believe it is a general purpose database. But if you're going to build anything, you don't reach for another database. You're like, why aren't you using a SQL database? You should be using a SQL database. And we know this, this is true. It's a general purpose database. You can do anything. So kind of the burden of proof, is on the developer to say, well, why we're not using a general purpose database for general purpose work. And at the same time, the category has been OLTP, which is kind of, we've all just grown comfortable that the two are the same. But actually, if you look at the history of the field, right in the beginning, the founder of OLTP, one of the people who helped coin the term ACID, for databases that guarantees atomicity, consistency, isolation, durability, Jim Gray, an incredible Microsoft researcher. He also coined the 5-minute rule. He worked on System R, where SQL came out of. So it was his work that led to the formation of the Transaction Processing Performance Council, TPC. They gave the industry, the database industry, the benchmarks for OLTP. And so it was actually Jim Gray who defined, in one of these very first benchmarks, what a transaction is. This was 40 years ago, exactly, this summer, 40 years ago in July. So, so this is the burning question now. What is a transaction? What did Jim Gray define it as? And in my mind, I've always thought that a transactions database is the same as a SQL transaction database, a general purpose database, because you can do anything with a SQL transaction. And so I always just conflated the two, transaction, SQL transaction. And now I just want to, come to the first principles part of the story, step back from the history, and we'll come back to, what did Jim Gray think? But on my journey as TigerBeetle working on the central bank switch, what we saw with the switch was it was so simple. It was really Alice pays Bob. That canonical example, money is moving from one row in the database to another. The problem was there were only like 8 rows. So you've literally got 8 rows because it's a central bank. In some countries, there are like 8 banks around the table, and there's 8 rows. This is a simplified example, but the high level, this is really what it is. It is so simple. It's 8 rows in a table, and each row has got an integer amount. And that could be financial, but it could also just be inventory. So this could be, like you're a shipping company and you've got 8 rows of like your hottest products. And I mean, you only have your Apple and you have 8 products. They can all fit. Steve Jobs has got that famous quote that all the products of Apple could fit on the boardroom table. And so you're selling 8 products, there's 8 rows. Again, simplistic example, but generally there's like Pareto principle. Often a lot of what a business sells, there's 8 kinds of it. Or say you're Google, you've got millions of customers, but you only have a handful of bank accounts. So you've got, again, it's 8 rows. Or obviously, they've got many more. It's this interesting thing where there's millions of something on the one hand, and on the other hand, there's just everything is flowing through these 8 rows. So, for example, for a country, millions of citizens, but 8 banks, 8 rows around the table. So ultimately, all these transactions are flowing through 8 rows, and you're moving numbers. And these numbers could be books in the world's biggest online bookshop, or it could be any kind of thing, just it's moving from one personal place to another. The specific example of the central bank was it's money. It doesn't have to be, but it was 8 rows, and they were trying to move lots of updates between these rows, and they were using a general purpose database. So you pop the hood of this car that they were building, and inside the engine is a general purpose engine. And you look at how it's working, and every time Alice is paying Bob, it's really that simple. There's tens of thousands of lines of code around the SQL database just to do that. But it is really, it is as embarrassingly simple as Alice pays Bob, this bank, and you're just moving pieces of paper, I owe you, and that's all. But there's a lot of code around a general purpose engine. But then you look at it in more detail and you see, wow, okay, Alice pays Bob, and there's 20 SQL queries. And really, like that was, some people get this down to one. You can do it, one for one. But there is a lot of business logic. So let me sketch it out for us. So Alice pays Bob, and what we saw was SQL transaction from your API server, stateless API layer, or your gateway, and you got a SQL transaction from there to your database, Postgres database, and SQL transaction, and straight away you select two rows. Select Alice's row, select Bob's row for update. Row locks. Both rows are row locked. And this goes back across the network, 0.5 millisecond round trip time. And then there's maybe one more SQL query, but generally the rule of thumb for many systems is 10 SQL queries to do all the business logic, because you have to also ask the question to the database, was this transaction processed before? We're still going to answer this question of what is a transaction, but within a SQL transaction, you see we're asking the database, was this transaction processed before? And really what we're meaning is, did Alice already pay Bob? This transaction between Alice and Bob, did this already happen? Because obviously the money should only move once, not twice or thrice. And so SQL transaction, row locks for Alice and Bob. And there's business logic. Did it happen before? And there's other things, so generally there's about 10 queries, or you could get it down to one, but one or two probably. But the problem is you've got row locks across the network. And that means that it's going to take about, 5 milliseconds to commit the SQL transaction in the end. And then you realize 1 second, there are only 1,000 milliseconds in 1 second. If it takes 5 milliseconds, that means we can do 200 of these transactions between Alice and Bob. And immediately someone's going to say, sure, but there's many Alices and many Bobs, so it's not that simple. We've got concurrency. But actually, when you look at these workloads, it's not possible because there are only 8 rows. As soon as you do a transaction between Alice, chances are very high that Alice is also doing other transactions at the same time with other banks. They're all transacting simultaneously. They're all row locked all the time. And so literally you've got this fundamental limit that, wow, your system can only do 200 transactions a second, maybe 1,000. Generally with Postgres, for a lot of systems, the limit works out to be about 1,000 TPS. Maybe you can do 5,000 and then you're starting to cut corners. And the reason again is that it's row locks, the general purpose SQL transaction design, interacting with network round trip time, which is a function of speed of light, which doesn't change. It's never going to get better. And the third thing is the number of SQL queries and contention in your workload, which usually for transaction processing is usually high. 80% of transactions involve the same 20% of rows. And for example, you're a warehouse and you're an electronics store, you sell electronics, you're selling Apple, you're selling Samsung, fine, many different rows. But as you sell Apple, you also want to touch the row that says, your total Apple stock sold today. And so there are only 2 rows, Apple or Samsung, maybe 3 or 4. Most, you see this everywhere when you start to look at it. So same problem as Ticketmaster. This is the classic example. They sell to millions of people. Most of those people just want Taylor Swift. So there's one Taylor Swift row. And that row just gets hammered and row locked, and these systems just go down. And the fun thing about this is you can throw hardware, give it NVMe, go horizontal, whatever you do, it doesn't change anything because the fundamental limit is there. SQL transactions, round trip time never changes. There's always locks, whether you go horizontal or not. Horizontal just makes it even worse because now you've got distributed locks. So this is the problem we spotted. And the long story, we're really going into the weeds here. We're going to come back to Jim Gray. What is a transaction? But we saw, for the purpose of the switch, a transaction is Alice paying Bob, which is implemented. The implementation is a SQL transaction, but there's an impedance mismatch because of this fundamental limit. And for years, this limit's always been there. It's been latent. For years, it's never been a problem. But we saw, with the switch already that the world is becoming more and more transactional. Instant payments volumes have exploded, 1,000x. People are moving from cash to digital. And, it's like the real world. We went onto the internet and scale exploded. And the same is happening for payments transactions. But the same is happening around the world in like in-game transactions, energy transactions, cloud transactions, and APIs. If you're a software engineer, you're probably selling an API and people are making API calls, and that's what you sell, your usage-based pricing. So in the past, we would sell things, once a month, and you would sell a game to somebody. Now you don't do that. You give them the game, and then every day they're buying little things from you. So you're far more transactional, more transactions with less value. And so this is what we saw also for the switch. And we realized, okay, this fundamental limit is now becoming a big problem. The world is changing, internet scale coming to all other sectors. And as sectors move on to the internet. And so we understood a transaction really is a debit credit. That is what really everybody needs, because for centuries, this has been the unit of a transaction. Debit Alice, credit Bob, an amount, a time. We call this the who, what, when, where, why, and how much of transaction processing as businesses transact, as startups transact. Whatever you're selling, essentially the most elegant schema you could come up with is the one that, the world has been using for centuries. Debit Alice, credit Bob. It could be debit this warehouse for this inventory, credit this warehouse as your trucks are moving some quantity, but it doesn't have to be financial. It's just counting, as you're moving counts across. So this was our first principles understanding, the fundamental problem. It's latent. It's now becoming existential. Systems are falling over. And the way to solve this, is a transaction is debit credit. Why not just put 8,000 of them in a 1 meg message? The debit credit information is for centuries, it's standardized. It's a standardized schema. Credit Bob, debit Alice, an amount, who, what, when, where, why, how much. It's about 128 bytes of information, 2 CPU cache lines. Let's put 8,000 in a 1 meg message. Let's send that across the network to the database and back. Single round trip, no rolocks. And now your whole API layer is just hitting that database 8,000 at a time. And suddenly you're doing 1 million transactions a second, and it's so easy. And you're amortizing the cost of networking, cost of f-sync to disk is amortized, cost of consensus, everything. There's so much mechanical sympathy here with this first principles design. If you see a transaction as a debit credit, and if you pack 8,000 of them you redesign the database from first principles and see this car needs a transactions database that can speak debit credit, as a first class primitive. It's so much, could get rid of all that complex, crazy expensive, tens of thousands of lines of code in that payment switch. Hang on, everybody needs one of these too. Every startup is transacting, doing business. This is how we started TigerBeetle. We built the whole thing from first principles, the whole database from the ground up, storage engine, consensus, everything. Love to go into those details with you, but this was the story, for 2 years. We started the company, then it's an open source project for 4 years. We then Coil, where I was working, they invested 3.2 million equally with Amplify Partners, other 3.2 million. So, my CEO invested in us. It was an amazing experience. And we have a founder-led startup 2 years ago. And this was all from first principles, just thinking, believing, this is really, it's necessary. It's from a real problem. And then last year, I was reading the history of transaction processing and still thinking in my mind, OLTP is Postgres and SQL transaction and conflating that. And then Andy Pavlo, of Carnegie Mellon, the famous, databaseologist, he even has a lab coat, saying databaseology. Andy Pavlo, professor, databases, Carnegie Mellon, I noticed something very strange. He referred to TigerBeetle as a transactions database, not a general purpose database. That just got me thinking. I thought, wow, that's weird. He just called us a transaction processing database, not a general purpose database. I always thought, well, we were just not a general purpose database. We were some specialized first principles thing. But then he called us transactions database. And I thought, wow, okay, that's Jim Gray. So I was reading the history of the transaction processing field, OLTP, and then something happened, Gregor, like I saw, wow, the very first benchmark that Jim Gray did, to measure transaction processing performance power, it was the paper, a measure of transaction processing performance power. The name of that benchmark was debit credit. How many debit credit transactions can your database do? And I think I fell off my chair and I thought, okay, this workload, we really solved this with TigerBeetle.
But it's a perfect loop, where the first principle effectively that you had been working from was the same. That is how he defined a transaction. I mean, my context of this, I took Accountancy 101 way back in the day. And to understand that, it was still, I think this is still helpful for the listener base, because I can imagine a lot of people have not studied accountancy. I've also run a business and been in the weeds on the accounting, so I understand it from that perspective as well. For every single credit, there has to be a debit. For every debit, there has to be a credit. There is no such thing as you can't pay something out of one account and it not have a corresponding other side to it. And this is a very strange concept, I think, for people to get their head around on day one. You say, well, I just pay myself a salary or I send some money out for this. It's like, yes, but which account is being debited or credited, either way around, right? It's just so interesting that as you have an amazing history, the history that you've recalled there, how that fundamental first principle there is debit and credit. Yeah.
It's like the first law of thermodynamics, money cannot be created nor destroyed. It can't just come out of thin air and go to the creative accountant's pocket, and this was what the world sort of evolved, double entry, for every debit, there's a credit, like you say. And because it's like the first law of thermodynamics, you can actually, just like that applies to the universe, you can apply this to the universe of business. And that's why it works so well. You can describe any kind of. This is what struck me with Jim Gray, is he thought of as a transaction is selling a theater ticket and you only want it sold once, but that is a debit and a credit. You debit your inventory of, theater tickets, that specific seat, and you credit an individual who bought it. Or an airline reservation, or a, Ticketmaster for Taylor Swift. It's all debit credit. It's a paradigm shift, but suddenly you realize, wow, I just hit upon the perfect schema. And yeah.
Amazing. So you've touched on a couple of things already that I was going to sort of ask about. I mean, you mentioned sort of in your materials being able to process 8,000 transactions in a single round trip without roll-locks. And, you've given some really great examples of how roll-lock even occurs. I think Taylor Swift example, that was a very good one. I sit only a few hundred meters away from a large stadium in Singapore, and she was performing there. So I know full well how many people must have had to have hit that Ticketmaster row.
Yeah.
It's insane. So could you maybe just briefly even just go into what does that look like when you mentioned, if I understand correctly, every round trip is always 8,000 transactions, either if they're sort of empty or full, or empty or have data, or how does that work?
It starts off small. So if your app is not doing a lot of, API calls, say you're counting all your API calls for a customer because it's usage-based pricing. So you're counting the number of calls, what types of calls they make, because that is what you're charging for. So you're a startup, you're selling your API, and you're counting the calls, the types of calls, and you're also doing the billing in real time so that you can say, okay, at this exact moment, they've done $5 worth. Okay, now they've hit their free tier limit. So now you've got the concept of real-time spend caps. And in real time, what your API usage is, but also what your API costs are, and also, what your sales price is for your customers. And so let's use this example. If your API isn't busy, you're only doing, you're starting off and you're doing one API call a second, then that is going to be a database query to TigerBeetle from your app. It's a nice stateless app layer, and TigerBeetle is a system of record with all the state. That's the hard part. But your API isn't busy, so it's going to be literally a 256 byte header plus 128 bytes debit credit for that one API call a second. So you're literally like, this is the first principles thing of TigerBeetle, is it's so efficient, 256 byte header on the network plus 128 bytes. That is a request per second that you're doing. And then as your app gets busy and suddenly Taylor Swift comes along, and your Ticketmaster decided to use your API under the hood as well. And now what will happen automatically, and TigerBeetle will do this for you. So your app doesn't have to worry about batching. You just send your individual calls to TigerBeetle to record as the how much your API is used and what the value of that is. But you do that one-on-one. The TigerBeetle client it's in your programming language like Node.js or Java or Go. You can, create accounts, create these debit credit transfers between them. Very simple. You just do one at a time. But that database driver or a client in your programming language is going to start batching it up. So as you're doing now 1 million a second, you've got a whole API layer around TigerBeetle. Those individual clients are now batching these up. So that network request goes from, on the order of like around 256 plus 128 bytes. Now it's going to fill up to a megabyte. But TigerBeetle does that transparently. So, but counterintuitively, you actually get better latency that way. Normally people think batching and latency are opposed. It's actually more of a U-shaped curve. So if you only do one network request per real world transaction, which would be the case with general purpose SQL, if you're really good, or it's usually even worse. So 10 SQL queries, for one real world thing. But let's say you do one for one, then you get worse latency because now you're paying all these fixed costs, the networking, the F-sync on the database, that's got a pretty much a fixed cost. So actually batching, you get this U-shaped curve, and latency, it's the same, but you're getting more throughput because now you're filling those fixed, size things with more things.
Right, got it. There's so many concepts and features of TigerBeetle we could cover, and we're unfortunately never going to be able to cover all of them today on this episode, so I'm going to have to be a little bit choosy, I think, on where we go. And I can only say I just encourage, obviously, anyone who's been listening so far and is interested, go to the TigerBeetle website, and there's tons of blog posts and there's lots of information that will fill in anything we are not able to cover today. There's so much there, which is amazing. So we're going to talk about one more in the sort of, again, a sort of slightly higher level concept and just sort of how you approached it. And then there's a couple of more specific things that are sort of TigerBeetle only that I'd love to get into. So just on the sort of higher level safety in this context, and you actually mentioned sort of implementing NASA's power of 10 rules and why that level of safety is crucial. Could you just speak a bit to all of that?
Yeah, thanks, Gregor. If anyone wants to dive in, the code is on GitHub, TigerBeetle/TigerBeetle on GitHub. And Matt Cladd on the team, he was the creator of Rust Analyzer, and he's live on Twitch every Thursday doing code walkthroughs, all like into the weeds of, we've done a few, but he does everything, all the design decisions in TigerBeetle, all the engineering there. We walk through the code live on Twitch. There were 2,000 people live on stream. We had a Twitch raid last week, so it was fun. But it's really a great way to learn about just general concepts, how to do consensus and how does a database work in general. And there's 32 episodes. Yeah, and it's all in Zig as well. So it's very easy to read, very nice to read the code. But yeah, to your question, I've actually can you remind me?
Of course. Yeah.
I got sidetracked there.
Of course.
Safety. Yeah, safety.
And NASA's 10 principles, yeah.
Okay, safety. Yeah, let's not forget safety. It doesn't matter if you're fast and buggy. So safety was the most important, actually. The performance, what we've covered, from first principles, that makes a difference in people's lives. I got goosebumps when I realized we could do, 100,000x, because that makes a big, big difference. But safety actually is the thing that is most exciting about TigerBeetle, because we realized, existing systems were 30 years old, literally, and they're fantastic. They're tried and tested. The flip side of that is actually they're tried and tested in the research, and there's so much great research, for example, from Wisconsin-Madison, Remzi Apache-Dussault, Andrea Apache-Dussault, They've been doing this for years, just showing how these databases actually fail. So they tried and tested. We know how they fail in the literature. What happens if the disk gets corrupt? And actually, most of these databases were not designed for that. So SQLite in the docs specifically says it expects to read from the disk what it wrote. So if you have a bug in XFS, like happened last year, where XFS will write to the wrong place on disk, that will break most databases today. They can't handle that. So they have checksums. Usually they're not on, but if you switch them on, they still won't protect you from this, because the checksums are only meant in the design to help the database recover from power loss. So in the database literature, they call this crash consistency model. Be consistent through a crash. But that model is not strong enough to survive faulty disk that writes to the wrong place or reads from the wrong place or corrupts data at rest. Many things go wrong with these systems, and users have found this in the wild. So there was fsyncgate, where Postgres took a routine storage fault. It didn't have to lose data, but Postgres, MySQL, all of them, they accelerated this into data loss. So something that shouldn't have led to data loss. And Craig Ringer on the Postgres mailing list, I think a lot of users just think this is noise. I'll just recover from backups. Actually, the database is accelerating these things and causing data loss when it shouldn't. And I think a lot of people just don't know, and they just recover from backups. But actually, there's fundamental design things that could be so much better today, because, we've had 30 years of research into how to build safer systems. Hardware has changed drastically. We've got NVMe, the way the band, we call it the 4 primary colors: network, storage, memory, and compute. They have 2 textures: bandwidth, latency. So at TigerBeetle, we say we're painting. We're sketching from first principles. We're painting with 4 primary colors: network, storage, memory, compute, bandwidth, latency, for all 4. But those 4 bandwidths in the last 30 years have totally changed. The way, today, network and storage bandwidth is plentiful. In the past, it wasn't. So you would spend CPU cycles and memory bandwidth. You would burn memory bandwidth trying to reschedule, how you work with disk. Today on Linux, you just say to your disk scheduler, I don't want scheduling because the disk is so fast. So everything has changed, but with safety too. So I had worked on systems where we used NASA's power of 10 rules, and I realized this is how you build safer systems. So for example, TigerBeetle at startup, we allocate everything we need for memory. All memory is allocated up front. In runtime, there's no malloc or free. So I had been in Node.js for 10 years as well and seen, GC pauses and what can go wrong. And I ran so far away from that. Normally you run into the arms of manual memory management and you're going, okay, we're going to do malloc and free, or we're going to use Rust and a systems language. We ran even past that and we said, well, we don't even want malloc or free. There should be no hidden allocations anywhere in the standard lib. We want this database to be rock solid, have explicit limits of resources, because this way you've got a well-defined piece of software and you can throw the Taylor Swift wave at it, and it's going to handle that wave, and whatever it can't handle will just wash over, and the system is still running. It's not going to out of memory on you. So this was also why we picked Zig, that we can be so explicit with memory. But this was all from the NASA power of 10 rules. So you want static memory allocation. You also want assertions. So what's interesting with TigerBeetle is we code it forwards and backwards. So normally if you're just trying to code something, you're just trying to make it work. Make it work, make it fast, make it pretty. I think Steve Jobs said that as well. Make it work, make it fast, make it pretty. So as software engineers, we just want to get it working. And so we're coding something positively to get it work. And that's it. And then we productionize it, polish it, and it's all positive and the thing works. So I had a bit of a security background I was a white hat ethical hacker breaking into systems, but also, how to defend systems. And what I realized is that hackers think differently. They know that programmers are coding, let's just make it work, let's just make it work. The hackers are thinking the negative space around this. How should it not work? What would be surprising? There's that Monty Python sketch, nobody expects and then they arrive on the scene. That's how hackers think. So they come at you with all the things you didn't expect. And so TigerBeetle is 2 pieces of code. We code what should work, and then we've got tons of code assertions on what should never happen. So what do we not expect? So, for example, normally if you're coding a for loop, you just code a for loop. TigerBeetle, there's negative code around this as well. We will assert how many times did we expect the for loop to run at a minimum, and then we will code and assert how many times do we expect the for loop to run at a maximum, or it's just a loop in general. This is the way hackers think, because if you don't code this negative space, hackers will exploit you there. We call them semantic gaps. It's the gaps between worlds, the negative gaps that hackers can step through, like in the Matrix, and they chain these doors together to come up with an exploit. But the flip side of security is safety.
Yeah, that was a really interesting concept. What you just described there, the negative space, almost sounds like, what would happen if you could effectively run unit tests every single time a function ran.
Yeah, perfect summary. Thank you so much.
Okay, right.
This way of thinking is like, I'm not going to write unit tests outside of my code. I'm just going to make my whole code, as you come into a function, check all the arguments. As you leave, check them. It's like unit tests in your code. That's so perfect, Gregor. Thanks.
Yeah, well, I just hadn't ever heard of this concept before. So I was like, wow, this just it almost seems so obvious when you hear it. Like, why don't we do this? And I guess basically, as you just mentioned, make it work, make it fast, make it pretty. And ultimately, most engineers, for various reasons, have to kind of move on after the make it works part. So. Yeah. And actually, these are TigerBeetle's technical values: make it work, safety; make it fast, performance; make it pretty, user experience. All 3, they are. I think the other thing is maybe developers don't want to put assertions in their code because they're worried that the system crashes. But actually, you want this, I think, because you want your database to either run correctly, or if it detects that it's being hacked, shut down safely. Again, I'm just using a hacker as a metaphor for a bug, because I think, the flip side of security is safety. So the same techniques work, and you can make rock solid software. It either runs correctly or shuts down safely. Because when software is autonomous and it runs very fast and something goes slightly wrong, it's like resonance, and then suddenly this whole supersonic vehicle explodes, a spaceship explodes. So you want these things to be so predictable and safe at high speed, or to shut down safely. Again, thorium reactor, passive cooling. You don't want your nuclear reactor to be active and explode. But then now, like to your point, unit tests, but in your code. Then what you do is you go and fuzz these systems. You just autonomously test them. I'm not... AI, it's a real thing. There's also a lot of hype. But the exciting thing for me is not autonomous coding, it's autonomous testing. We've actually had this for years. Let's just write little computer programs that will autonomously send Taylor Swift load. And then you fuzz these systems like anything. And then the slightest thing goes wrong, your unit tests are now going to be activated in your code and they shut down. Straight away, okay, there's the bug. Your debugging velocity is so much faster, and all this is deterministic. You're not trying to, I've worked on systems distributed where there's a bug and it takes you 2 years to find and fix it. But this technique, we call it Tiger style. So there's a whole doc you can read about this methodology, Tiger style. There's a talk on our YouTube as well. And this is, it's NASA's power of 10, static allocation, limits on everything, assertions everywhere, plus fuzzing, plus what we call deterministic simulation testing. So you can even abstract time and speed up time. We do this by a factor of 700x. So now you're testing like literally, we run 100 simulated cores 24/7 for TigerBeetle, simulating. We abstract and speed up time 700 times. So, 100 cores for a day times 700 is 2 centuries of testing. Whereas otherwise, you're running a database in real time. So you only get, 30 years of testing across a few million users. But
these techniques are so much safer. So this is kind of why I say, that this is probably the most exciting part about TigerBeetle is the testing and the Tiger style stuff. Yeah.
Yeah, I was going to definitely move on to this, and partly because not only is this, you call it Tiger style and deterministic testing, in itself is already a pretty huge feat to overcome. But I love how you guys just took it one step further, which is to put a whole game around it. And you have Sim TigerBeetle, which I've played. Please, this is amazing. Just describe Sim TigerBeetle and what was the story behind that? And yeah.
Oh, I'm so glad to hear that. I'm so glad you've played it. And you say that you've played it because everybody is like, well, where's the game? And we're like, well, it's a walking sim. But we did put a game within a game. At the end, if you get to Radioactive, there's actually a platformer and you can jump up and get your highest score. But the story behind that was I realized we've got a problem. We've made this database and it's all invisible. My favorite things are all invisible, stories and music. You can't see them. Software, you can't see it. So, we've talked about time travel like Interstellar. Let's run our database on a planet where time moves faster and we test it to age it quicker. And that's Interstellar. But the other movie of TigerBeetle is like Inception, which is the simulation so you run real code in a simulator. It doesn't even know it's in a simulation, but it is. That's how you do storage fault injection and all those things. But then taking Inception a bit further, we took, TigerBeetle. It's running in the simulator. That's how we normally test it. The problem is it's all at the terminal. So nobody sees this. It's invisible. And we were going to go to MozFest in Amsterdam. It didn't happen because of COVID, unfortunately. But we were going to be there at MozFest in Amsterdam, and we were going to be in like a TigerBeetle house. And I knew there would be these Mozillans and they would bring their kids. And then I knew like the poor kids, they're going to come and see like a terminal. And they're not going to connect with the world of databases, and they're not going to become programmers. They're not going to become computer scientists. They'll become scientists. So like my daughter, she says to me, Papa, I'm going to become a scientist. And I said to her, yes, computer science is also, it's part, no pressure, obviously. But the wonderful thing was I thought, well, how do we show like adults and kids Pixar style, like this is a database? How can they see these things, see the fault injection, see the cosmic rays hitting the disk and the TigerBeetle survives? So what we did was like Inception, we went into a deeper dream and we took the database running in a simulator. Then the simulator, thanks to Zig, compiled to WASM running in a browser tab. And then we put a graphical skin on top. There's a port of the Nano VG game engine to Zig that Fabio Arnold did. And he's also on the team, and he and Joey, our illustrator, it was a part-time project for a long time, and they did so much with so little in a short time. And then you've got this actual game over TigerBeetle, kind of inspired by our childhoods, also like Worms and Scorched Earth, because these were all games that the level is generated from a deterministic seed. And, we had the same thing in our simulator. So we thought, what if we give people 3 different cartridges they can play? The network storage is perfect. See how TigerBeetle runs, see some clients. There's a few movie references like Agent Smith from The Matrix wears the glasses in the first level. There's a Captain America in there. And so, yeah, this was the game.
Was this developed in-house, or did you kind of go to some specialty, more game developers for this? This is obviously a complete sidebar. I'm just curious how
yeah. So at the time, I was working for Coil. This was the company in San Francisco, and we were working on the Switch. And then TigerBeetle became an open source project full-time at Coil. It's an amazing company. And then we realized, okay, we're going to go to MozFest. We need a demo. So I was reaching out to game developers, but I couldn't find any. But in the Zig community, then I found like Fabio Arnold. And so he was doing this part-time for us, not in-house. It was like a Skunkworks project with the illustrator Joey, also part-time. And they're now full-time on the team. This was 3 years ago. So it was just credit to Coil as a company and the Zig community. You meet these amazing surfers that can spot this quality swell from far away, and they're paddling out to the swell. They don't care how many surfers are on the wave. They just see, wow, Zig is quality, and they're there. So we were just lucky because I went to Milan to one of the first Zig meetups in Europe. And I met Fabio, and he actually demoed a game he made with Zig, and I thought, okay, this is perfect, So it's pretty cool what they did. Hey, how you see the screen shake and the lightning flash.
Oh, it's incredible. And my first question was just how on earth did they had this thing all kind of, what was the inception of this, and how did it all come together? And so I think that's just a great little side quest story, if you like, for TigerBeetle. Just moving it back to the fundamental system itself, so as you said, safety is one of the most exciting kind of parts. And I think, it's been very interesting to hear exactly how that has all unfolded. Coming back to maybe one more sort of slightly more in the weeds part in terms of how the system actually adds concepts for, back to this is fundamentally a debit credit driven database. And you have, I guess, what you've kind of called financial primitives, such as T accounts and two-phase transfers. Like, how have you actually sort of implemented? Let's talk about what are those, and then sort of what were sort of the challenges in actually implementing them at the sort of system level.
Okay, thanks. Yeah, so this is the thing: is TigerBeetle's not just a record of debit credits; it gives you actually a rich set of primitives designed around debit credit. So it's, excuse the analogy, but it's like Redis for debit credit. You get all these debit credit primitives that you can play with and build things with to power your startup's business transactions, whether it's API calls that you're tracking or whatever. So let me give an example now. We've got something called a two-phase debit credit. So one of the biggest importers in the US reached out to us because they really like this primitive, because they've got a massive shipping fleet around the world with real-time inventory on ships that they track with satellites. They've got a few hundred trucks across the US and all these depot branches, and they're moving physical materials from one branch to another with a truck. So they've got a count of physical hardware material moving from one branch to another with a truck. Debit credit. The challenge is that the truck is in flight and they don't know, when is the truck getting to the branch? Did it get to the branch, or did it just get, did it disappear? Or did things disappear while on the truck in transit? So you've got this question of time. And so really it's a two-phase debit credit. They're saying, look, these quantity of goods are no longer in this branch. They're in the truck. This truck is in flight. We expect it to be there within a day or two, or otherwise there's a timeout and it rolls back, or we have to go and investigate. So you've got this situation where some quantity of goods, it's not in warehouse A, it's not in warehouse B either, it's on the truck. So it's in flight. But you know that it's supposed to be at warehouse A. If something goes wrong, it should go back there. So this is something you can just do in a single round trip with TigerBeetle. And you can do 8,000 of these two-phase debit credits. Another example is like a credit card transaction. As you tap, it's authorize, and then a little bit later it gets confirmed, captured. That is a two-phase debit credit. So you authorize, you reserving the funds, and they're about to move. And then in the second phase, that gets committed and posted. And you can use this very nicely where you're a startup, you're building something internally, but you have to now go to Stripe and get them to do a transaction for you, and you're waiting on that. So you can reserve your inventory or your Ticketmaster seat. You reserve that. Somebody has now chosen their seat, so you reserve that with a two-phase debit credit, so no one else can book it. And now you're waiting for Stripe to do the payment transaction. And maybe you'll set an hour timeout. So if Stripe fails, you will release that seat back so people can book it again. And TigerBeetle makes that so easy. It's just one round trip to the database. Trying to do that with SQL would be, this was actually where the 10,000 lines of code in that central bank switch, because they were trying to do this. So we realized, wow, this would be very cool if you had it at a first class primitive. And it's kind of exciting how people build with this, So there's a gaming startup and their whole virtual inventory is in TigerBeetle, and you could use these kinds of things.
Yeah, that's always a really fun and interesting examples. And I guess as we're sort of wrapping up here, as you've now sort of alluded, people willing to kind of get going with TigerBeetle, what is the best way, if you're a developer, and obviously I think most people will be pretty excited by what they've heard today. So where to go, how to get going. Yeah.
Yeah, so GitHub, TigerBeetle/TigerBeetle, open source is there. From there, you've got our docs and Slack. We've got a whole community Slack. Around about 1,000 developers are there, all comparing notes, like very cool recipes, how to build things on top of these primitives, help with like operating it. We help as well as a team. So there's that too. But yeah, GitHub and Slack. And again, yeah, Twitch, Iron Beetle, the show by Matt Cladd every Thursday. That's more if you want to really understand how TigerBeetle is built. And if you want to understand how to build with TigerBeetle, that'll be our Slack.
Very cool. And, we're recording here in just turned to August. It's August now. Just for the listeners that are listening so know when we were talking, you've just announced Series A funding, I believe. So congratulations, as well as, maybe too much hype is put on congratulating the funding and not the business. I don't think there's any trouble with us congratulating the business in this case. But, what will that funding enable you to do, I guess? And how does that sort of change the perceived, in your mind, trajectory for TigerBeetle?
Yeah, no, thank you, Gregor, for the kind words, and agreed with you. So the Series A is really we've just been entrusted with more. When we spun the company out from Coil, it was very much like, our CEO was sending us out, a team of gardeners, plant a seed and tend to it and look after it and make it grow, as a business and serve the community honorably at a profit. And then really nothing has changed. So the Series A, when we raised it, one of the engineers said to me, because we talk about catching rain with buckets, let's put the buckets out there, catch the rain that's falling, let's not let it be wasted. And he said to me, wow, we can buy a lot of buckets with this. And it's the same thing, more water to water the tree, tend to the garden, make it grow. You're entrusted with something. That's all it is. The level of trust has increased. So we'll be using it to serve the community honorably at profit, building the business to support TigerBeetle, the cloud platform. You can just push a button and you've got a TigerBeetle running. We're already using it now to work with customers. Singapore, there's 2, London as well, and around the world. And we send our engineers to work with people. But we can start to do this, because we've got the means. So it's really building out the business to serve TigerBeetle, give people a better experience, and develop the database, of course. So,
of course.
Yeah, and it's
amazing.
Oh, just to add, the very cool thing was our lead investor for the A is Natalie Vase. I've known her before TigerBeetle was a company, and she's a database engineer. She was at Oracle, then she was at Google for Cloud Firestore. And so very technical person. We actually met through Jamie Brandon's Tradboy niche database conference. So pretty good alignment, all believing in the, this future of transaction processing.
Yeah, I think it's a really great call out. Is obviously not all businesses need or want funding, but if that is the route that you have decided you'd like to take, then finding alignment is like the sort of holy grail almost, that the investor shares just as deep a level of the vision and the product as you do. So it sounds like you found that, which is more than deserved, I think is the best way to describe it, given sort of the amount of time and dedication clearly you put into this. Yeah.
No, well, thanks. I think it just comes back to that little beetle, that's done all the work. We kind of just discovered it, Don and I, on that payment switch.
Amazing. Joran, thank you so much for coming on today. I think I don't like to have favorites, but this has probably been a favorite conversation so far of 2024. So I really appreciate you coming on, and hope we get to meet in the future, perhaps. I think many SE Daily listeners realize, obviously, most of our episodes, it was 2 people sitting in 2 very different countries. So yeah, maybe we'll meet at a niche database conference or something along those lines.
Can't wait, Gregor. It's been awesome. Thanks so much. It's been a favorite of mine too.